Now let's move on to the next topic. This is now factoring. So we have here the formulas now for special factoring formulas, because this is quite different from here, actually the reverse way, because the title for that is special products formulas and the other one is special factoring formulas. Okay, let's try to be familiarize the formula. Although if you are familiar with the special products formulas, so you can also get this one. All right, number one, we have the difference of squares. I will call that one as difference of two squares. So a squared minus b squared, whose factor for that is a minus b times a plus b, or simply take the square root of the first term, which is now a, and the square root of the last term, which is b, and then duplicate and then change the sign. But assign negative and positive or negative, in other ways, combination. All right. Now, for number two, we have this is a perfect squares, or I called this one a while ago as perfect trinomial square or perfect square trinomial. So we have a squared plus 2ab plus b squared, whose factor for that is the square of binomial, or as square of difference, or sum of a square. So in that case, so I call this one now as, you can call as perfect square, but I usually call this one as the square of binomial. And number three, we have a squared minus 2ab plus b squared. So whose factor for this is the square of a minus b. And this is now the difference of cubes, or difference of two cubes. So you first of all, you're going to take the cube root of the first term, which is now a, and the cube root of the last term. We have now copy the sign of negative b. That's the first thing that you're going to do. Take the roots. Okay, so the cube root of a cube is a, and the cube root of b cube is b. So a minus b. That's now your binomial. Now the next term, the polynomial or the trinomial term, is actually coming from the binomial of a minus b. So now you square the first term. We have a squared, and then take the product of the two terms. We have now a times b is ab, and get the opposite sign. We have positive ab and the square of the last term. And for the number 5, the sum of cubes, or the sum of two cubes, we have a cube plus b cube. So almost similar with this. First, take the roots. The cube root of a cube is a, copy the sign, plus, and the cube root of b is b. And then, to come up with the trinomial, you square the first term. That's why a squared. Take the opposite sign. Then they have minus, and the product of the two terms is ab, and plus the square of the last term. Okay, so now let's apply these formulas now to the next example. So factor each expression. So number one, we have, or a, we have 4x squared minus 25. So 4x squared in the first term is a perfect square, and the second term 25 is also a perfect square. So I call this one now as difference of two squares. So first of all, I will write the formula for that. So this can be written as a squared minus b squared, whose factor for this is a plus b times the quantity of a minus b. All right, so applying this example, we have 4x squared minus 25. So what is the square root of 4x squared? We have 2x plus the square root of 25 is 5. And then duplicate this one, but change the sign. It becomes now 2x minus 5. So whichever comes first, either 2x minus 5 or 2x plus 5, it doesn't matter because of the commutative property. All right, so for letter B, we have the square of x plus y minus the square of z, or z squared. So this one will be the first term, and this one is the second term. So the first term is a perfect square, and it is in binomial form. So we just take the square root of this. So the square root of the square of x plus y is just x plus y. And then we can write minus or plus first, and then the square root of z squared is z. And then, so We're gonna change the sign now. I have x plus y. So this one, the sign for this will not be changed because it is grouped as it is binomial term as our first term. So the second term is z. So we can change the sign now from negative to positive z. Or I can use that one first so that you will not be confused. All right. And then simplify further. We can write now x. Removing the parentheses, we have x plus y minus z times x plus y plus z. Okay? A trinomial is a perfect square if it is of the form a squared plus 2ab plus b squared or a squared minus 2ab plus b squared. So we recognize a perfect square if the middle term is 2ab or minus 2ab. Or we could say that twice the product of the square roots of the outer two terms. So the outer two terms, we have a squared and b squared. So the square roots of that is a, and the square root of b squared is b. So we have twice the product of the square roots. Where that is now for your middle term. Okay? So factor each trinomial. So is this in the form of a perfect trinomial square? We will see. The characteristic or the property is should be the first term and the last term must be a perfect square. And for the middle term, it should be twice the product of their squares. So we could say now that the square root of x squared is x times the square root of 9 is 3 and then twice. So twice to that, we have the product for this now will give you 6x. This is now x times 3 is 3x times 2 will give you now 6x. So therefore, x squared plus 6x plus 9, so whose factor for that now becomes, we have x plus 3, the square. As you can see here, this is now the perfect square trinomial whose factor for that is a square of binomial. Let me show you again. That is now in number 2. So a squared plus 2ab plus b squared whose factor for that is the square of binomial. And that's what I did here. So for the letter B, we have 4x squared minus 4xy plus y squared. So we will check the first term, all right? So the square root of this is 2x, and the square root of this is, we have y, and then twice. So we have here 2x times y is 2xy times 2, we have 4xy. So since the sign is negative, so we expect that our answer for that will be negative sign as well. So we can write now, we have the square root is, the first term is 2x, so we could write 2x. And since the sign is minus, so write there minus y and then u squared. Okay, this one, the one that I have shown here is actually, I'm showing that for the middle term. So this is now for the middle term. We have 4xy. So the negative sign there will reflect it here. So the square of binomial. Next, we have factoring differences and sum of cubes. All right. So this, let's apply the formula number 4 or number 5. So for this problem, 27x cubed minus 1. So the first term is 27 and the last term is 1. So what is now the cube root of 27x cubed? So the cube root of 27 is 3 and the cube root of x cubed is x. And the cube root of 1 is 1. I write here minus because of the minus sign there. But before that, let me recall you the formula for this. Our formula for this, we have a cubed minus b cubed, whose factor for that is a minus b times a squared plus the square of the first term. Then take the opposite sign. we have the product of A and B, A, B, and then plus the square of the last term. So we have here, so we have now I have written already here the roots of the first and the last term. So the cube root of 27. So we have 3x minus 1 times the square of the first term. We have 3x and then square. Then I will write plus the product of the two terms, 3x times 1 plus the square of the last term. Now simplifying that, so I'll copy the first binomial, which is actually the roots of the first and the last term. We have 3x minus 1 times the square of 3x is 9x squared plus 3x times 1 is 3x plus the square of 1 is 1. Okay, and next for letter B, we have x to the power of 6 plus 8. Now, what is now the cube root of x raised to 6? So, now let's take this one. So, what is the cube root of x to the power of 6? And what is the cube root of 8? Now, the cube root of x raised to 6 can be written as x raised to 6 over 3. Or simply, x squared, because 6 divided by 3 is 2. And the cube root of 8 is just equal to 2. Now, we'll write again here, x raised to 6 plus 8. So using that formula, the roots now are x squared. This is positive, so I will write positive. And the cube root of 8 is 2. That is now our binomial. So it's similar to a minus b. Since it's plus, it should be a plus b. Now, the trinomial will be coming from this. We have the square of the first term. I have x squared and then raise the power of 2 minus, we have to take the opposite sign, minus the product of the two terms. We have x squared times 2. We have 2x squared plus the square of the last term. We have 2 squared. Take note, in factoring the cubes, the middle term here in the trinomial is not twice the product of the roots. Okay? That's only applicable for the perfect squares or perfect trinomial squares. But for factoring the difference and sum of cubes, so there's no constant of 2. Alright? So it just happened that product of this is 2x squared for the middle term in the trinomial term. So we have x squared plus 2 times, you simplify this one, yeah, the square of x squared is x raised to 4 minus 2x squared plus 4. And this is now the factor of x to the power of 6 plus 8. So next example, we are going to factor the expressions completely, meaning to say we need to apply the different methods of factoring. So let's apply first common monomial factor if there is common factor. Between 2 and 8, the common factor is 2. So we can write here letter A, 2x raised to 4 minus 8x squared. So the common factor is 2. Then for the variable, the lowest exponent is x squared. And this is a common factor. Now, divide the given with the common factor. 2x raised to 4 means that divided by 2x squared. So the quotient is just x squared. And 8x squared divided by 2x squared. So the quotient is just 4. Now, we are not going to stop here because x squared minus 4 is factorable. Alright? So meaning to say, I'm going to factor again the x squared minus 4, which is actually the difference of two squares. So we can write here now as 2x squared. And the factor of this, the difference of 2 squared, we have x, the square root of x squared is x, the minus, the square root of 4 is 2, and then copy the terms, change the sign. So we have x plus 2. Remember that the factor of difference of 2 squared is in the form of the product of sum and difference of two terms. So this is now the final answer for letter A. Now what about letter B? We have x to the fifth power y squared minus xy raised to 6. So common factor between x. So the lowest exponent is x. We have x. And the lowest exponent in terms of y is y squared. All right. So divide this one, the first term with the common factor, x raised to the fifth power y squared becomes x to the fifth, and x we have x to the fourth power, and y squared divided by y squared is just 1, so no need to write 1, minus x y to the sixth power divided by x y squared, or we could use it x divided by x is 1, so y to the sixth power divided by y squared, so we have y to the fourth power. And again, this one is still factorable. That is now a difference of 2 squares. Why difference of 2 squares? Because the power of 4 is still a perfect square. Now let us expand further. So we have x y squared times, so difference of 2 squares, square root of x to the fourth power is x squared. And we have plus, or you can write either plus or minus first, and then the square root of y to the fourth power is y squared. And then we have to copy the terms but change the sign. We have x squared minus y squared. So after that, we have to inspect if we still have a given part of the answer now that is still factorable. Sum of 2 squares is not factorable, but difference of 2 squares is factorable. Now, we are going to copy the terms that is not factorable anymore, but the terms that is still factorable, then we have to factor further. All right? So, we have x y squared times x squared plus y squared. Take note, the sum of 2 squares is not factorable, but sum of 2 cubes is factorable. All right? And the factor of x squared minus y squared is the square root of x squared is x, the square root of y squared is y, so I will write plus y and x minus y. Because the factor of difference of 2 squares, as I've said earlier, it is the product of sum and difference of 2 terms. And this is now the complete factorization of the given. So next we have factoring expressions with a fractional exponents. So how to do that? First, we are going to apply first common monomial factor. So to factor the expressions with fractional exponent, so this is just similar to what we have done a while ago. So we have to factor out with the smallest exponent. But among the exponents, we have 3 halves, positive 1 half, and negative 1 half. So therefore, the smallest exponent is to the power of negative 1 half. But what about their numerical coefficients? Between 3, 9, and 6, so the lowest coefficient is 3. So we could write now for letter A, we have 3x. Since the lowest exponent is to the power of negative 1 half, so I write negative 1 half. I will write properly negative 1 half. Okay, the common factor is 3x to the power of negative 1 over 2, or negative 1 half. So dividing this one, 3x to the power of 3 halves divided by 3x to the power of negative 1 half. So the quotient is x to the power of 2. How do we solve for that? You divide numerical coefficients by numerical coefficients, and then in dividing base with exponents, the same base, and dividing the base with the exponents, so the exponents will be subtracted. So in this case, we are going to subtract 3 halves minus negative 1 half. And the quotient for that, it becomes 2. So therefore, the answer now for the first term is x squared. So minus 9 divided by 3 is 3. I start first with the numerical coefficients. Now, dividing x raised to 1 half divided by x to the power of negative 1 half. So the same base, we can subtract the exponents. So what is 1 half minus negative 1 half? So the answer is equal to 1. So we could write now just x or 3x. No need to write the exponent of 1. And then the next term plus 6x to the power of negative 1 half divided by 3x to the power of negative 1 half. So we just have 6 divided by 3 is 2. And since x raised to the power of negative 1 half divided by the same number, which is x to the power of negative 1 half, that's just equal to 1. And 1. So we just canceled there the x to the power of negative 1 half. So we have here, now the answer becomes 3x to the power of negative 1 half times x squared minus 3x plus 2. But you try to check if the trinomial is factorable. Alright? So the first term is a perfect square, but the last term is not a perfect square. But we can apply the factoring trinomials. This is what we did a while ago. So find the factors of 2 that will give you a sum of negative 3. So I can give negative 2 and negative 1. Negative 2 times negative 1, whose product now is positive 2. But if we are going to add the factors of negative 2 and negative 1, will give you negative 3. So therefore, you can write now the factors of this. So I will start first writing the common monomial factor of 3x to the power of negative 1 half times, we have x minus 2. The factors is negative 2. And the other one is x minus 1. So x there is coming from the square root of x squared. So we have x and x. So therefore, that's now the answer. Now for letter B, we have to factor out first the power of 2 plus x, because this one is 2 plus x to the power of negative 2/3, and there's another one which is now x. Okay, and this one 2 plus x to the power of 1/3. The first term is a product of 2 plus x to the power of negative 2/3 and x. And the last term, or the second term or last term, we have 2 plus x to the power of 1/3. So in that case, we are going to apply first common monomial factor, whose common monomial factor now is 2 plus x with the lowest exponent, which is now, the lowest exponent now is negative 2/3. Comparing negative 2/3 and 1/3, of course, the negative sign and the other one is positive, so we take the negative sign, which is the lowest one. So negative 2/3. And then we are going to divide the common factor. So the first term divided by this common monomial factor, so the quotient is just x, which is this one, plus the second term, this one, 2x plus x, the quantity of that is raised to the power of 1/3 divided by 2 plus x to the power of negative 2/3. So the base are the same. So copy the base first, 2 plus x, and then what should be the exponent? So since the base are the same, which is the binomial, then we have to subtract the exponents, which is now 1/3 minus negative 2/3. So the exponent is just 1. All right, maybe we're going to subtract their exponents of 1/3 and negative 2/3. So the result is 1. So no need to write the power of 1, or you can simplify further inside the bracket. So we can write now 2 plus x to the power of negative 2/3 times, we are going to write it now. We have x plus 2 plus x. So we have 2 plus 2x. Or we can factor this one. We have now the common factor of 2 plus 2x is 2. I will write here 2. And then I'll copy this one. 2 plus x to the power of negative 2/3. Take note, this 2 is a common factor from 2 plus 2x. And then we have to divide 2 plus 2x divided by 2. We can write now 1 plus x, or you can do the reverse way, x plus 1. So therefore, the final answer is 2 times the quantity of 2 plus x, the power of negative 2/3, times 1 plus x. And this is now my last slide for this topic. So polynomial with at least 4 terms can sometimes be factored by grouping terms. So the following example will illustrate this idea. So we have factor each polynomial of x cubed plus x squared plus 4x plus 4. So I'm going to combine first and the second term. So I can group as x cubed plus x squared will be grouped together. And the third sign is positive. So combining this one as well, we have 4x plus 4. So on the first group, so there is a common factor of x squared. Then you factor this again. So this one divided by x squared, so we have x plus 1 plus 4x plus 4, whose common factor is 4, so we'll write 4 times x plus 1. Now, as you can see, there is another again, a common factor, which is x plus 1. Now, I will factor out the common factor, which is the x plus 1. So I will write x plus 1 is a common factor. So this one, the first term divided by x plus 1. So x plus 1 is cancelled. So the remaining term is x squared plus this term, 4 times x plus 1 divided by x plus 1. So x plus 1 is cancelled. The remaining term is 4. But this one is x squared plus 4 is a sum of two squares. As I've said earlier, there is no such factor for the sum of two squares. So I can just write here x plus 1 times x squared plus 4 is our final answer. All right. So next we have x cubed minus 2x squared minus 9x plus 18. So if I'm going to group together the first two terms, and the last two terms will be grouped together as well. So I will group this one together, that one and this one. We have x cubed minus 2x squared will be grouped together. First term, second term, and the third term, since the third term is negative, so I will put here negative outside. But take note the rules. If it's negative, so the sign here will be changed. This becomes now 9x minus 18. All right. So this one again. So what's the factor for that? So we apply common monomial factor. So x cubed minus 2x squared, whose common monomial factor for this is just x squared. And then this term will be divided by x squared. So the quotient now becomes x. So first term is x minus 2 minus common monomial factor here is 9. So minus 9 times x minus 2. So as you can see it here again, this one and this one are common. So factor out that common factor. So I will write here x minus 2 and then divide. So this term will be divided by x minus 2. So whose quotient now is just x squared. And then this term again. So that one. So negative 9 of x minus 2 divided by x minus 2. So the quotient for that is just negative 9. But this one, x squared minus 9 is still factorable. Now we are going to factor that further. So we are going to factor that one. So copy the first binomial of x minus 2. So since this is difference of 2 squared, whose factor for that is just the product of sum and difference of two terms. So by taking only the square root of the first term and the last term. So the square root of x squared is x. The square root of 9 is 3. So I will use first plus. So plus 3 and then copy the terms but change the sign. So x minus 3. And this is now the factor, the given.